Hello children, so welcome to aimsindia's online classes. Today from physics subject, motion topic we are going to learn. So next, so we have two more terms, speed and velocity. We have two more terms, one is speed, another one is velocity. Suppose a car here, so a car is moving in different directions. It covered some distance, yes, in some time t, means the distance traveled by the car in some time, that is called speed of the car. So speed means distance traveled by a body in unit time. Suppose it went 80 kilometers. It went 80 kilometers in 2 hours. But we have to calculate in 1 hour in unit time. So 80 by 2. If we divide, we will get 40 kilometer. 40 kilometer per 1 hour. Per 1 hour. This 1 hour is unit time. In unit time, how much distance it has traveled? It is called speed. So here 80 kilometer is not the speed. 80 kilometer is the distance traveled in 2 hours. But we want in unit time interval. Means 80 divided by 2. Then we will get 40 kilometer per hour. That will be the speed. So speed means total distance by total time. Because here distance is a scalar quantity. What is scalar quantity, children? Which never depends on direction, which has only magnitude, is called a scalar. Because speed, in the formula of speed, we have distance, which is a scalar. So speed also a scalar quantity. For speed, no direction will be there. And the unit of speed is unit of distance by unit of time. What is the unit of distance? Meter. What is the unit of time? Second. So unit of speed is meter per second. Suppose if the truck traveling in a straight line, so whatever journey it has traveled, it is considered as displacement, not distance, because it is going in definite direction along a straight line. The car has covered this one, displacement. The car has covered displacement. So displacement by time. Displacement by time. Okay. Displacement by time. In how much time, how much displacement it has covered. If we divide, we will get displacement traveled in unit time, or displacement also can be considered as distance traveled in specified direction. If distance only, if it happens in particular direction, we call it as a displacement. We call it as a displacement. So velocity equal to displacement by time. It's a vector quantity. It gives direction. From SI unit of velocity is SI unit of displacement by SI unit of time. Its unit also meter per second. So speed means distance traveled in unit time interval. Velocity means distance traveled in specified direction in unit time interval. Or we can call displacement traveled in unit time. In any way we can call. Okay. So next. Suppose car covers distance of 20 km due east in 2 hours. Truck covers 60 km in 3 hours due west. What is the speed and velocity? Speed of car means speed of car 20 by in 2 hours. 20 by 2, 10 km. Speed of truck, speed of truck 60 by 3, 20 km per hour. Because 60 km it covered in 3 hours. 60 by 3, 20 km per hour. Here 20 kilometers in 2 hours. 20 by 2, 10 km per hour. So speed of car 10 km per hour, speed of truck 20 km per hour. In the same way, velocity of car 20 by 2, 10 km per hour. But here only value we will mention 10 km per hour. But here along with value 10 km per hour, it is going due east. Here the word due means towards children, towards that side, towards east, 10 km due east. So velocity of truck 20 km due west. Like that, while mentioning velocity, we have to mention the direction. While mentioning speed, no need to mention the direction, only value we have to mention. Okay. Next one. Next, speed means here distance by time means how much distance, distance traveled in unit time. So whenever we are comparing the quantity with time, so then we have to define it as the rate at which a particle covers a distance. Means the rate of distance, the rate of change of distance. The rate of change of distance is called speed. Why we are using the word rate here? Because we are checking the distance with respect to time. So that's why we have to use the word rate. So the rate at which a particle covers a distance along a given path is called speed. So speed equals to distance by time. Its basic unit is SI unit is meter per second, CGS unit is centimeter per second. So speed, because it is depending on distance, that's why it is a scalar quantity. What is the dimensional formula of speed here? Distance means length, time means capital T. So here L one time we are having, T one time we are having, but T is in the denominator. If we take to numerator part, it will become T power minus 1. L power T power minus 1. There is no mass here. So mass is not involved in this unit. So dimensional formula of speed is m0 L1 T minus 1. Okay. So the other general units of speed are kilometer per hour. Kilometer per hour. Because for buses and large big vehicles, we make use of the unit kilometer per hour. We call it as kmph. Km stands for kilometer, P stands for per, H stands for hour. Kilometer per 1 hour. Or we can also write it as kilometer by hour. Like that also we can write. So the SI unit is meter per second, CGS unit is centimeter per second, general unit is kilometer per hour. Not only that, nowadays we can broadband speed, worldwide broadband speed, or worldwide internet speed. So download speed 46.12 Mbps, megabytes per second. Because for internet or for your phone, you will be having RAM or memory. So 2 GB, 4 GB. 2 GB means they are gigabyte. Here MB means megabyte. 46.12 megabytes. What is this? Average download speed. In the same way, upload speed 22.44 Mbps. Means if you are downloading any video from YouTube or somewhere else, it will download with greater speed. Same way, if you want to upload our video somewhere else, so then its upload speed is somewhat less compared to download speed. So that's why for downloading it will take less time, but for uploading it will take more time. Next one. So velocity. Velocity means rate of change of displacement. Means rate of means with respect to time. Change of displacement with respect to time. Change of displacement with respect to time. Velocity is called velocity. So its unit same. SI unit meter per second. CGS unit centimeter per second. It is a vector quantity. Why means it is depending on displacement, which is a vector. Here time is a scalar. No need to bother about time here, but displacement is a vector. So velocity is a vector quantity. Dimensional formula also same here. Dimensional formula also same here. So here velocity means speed plus direction. If this cycle it is coming down and going up, coming back to point B. This cycle from starting from point A, coming down, going up, coming down, coming to point B. This is called speed. This length is called speed. Suppose if the cycle goes in straight line, so then it is having speed plus direction. So then its speed is called velocity. So velocity is nothing but speed in definite direction. Speed in definite direction is called velocity. If the direction is not definite, then it is called speed. Next one. So here, change of velocity. So the velocity of a particle or a moving body, when it will change, if the magnitude is changed. Suppose here we are pedaling the cycle. If we change the speed of pedaling, or while moving on bike, while traveling on bike, if we raise the accelerator, so then its velocity will increase. So that is one reason. So by increasing the force, either it might be because of pedaling, or might be because of engine of car, any reason. If the magnitude value is changed, then velocity will change. Or if direction changes, then also velocity changes. Or both changes while taking a sudden turn. Suppose we are going in car on ring road, on outer ring road, what we have to do? So if you are moving on a car, on the outer ring road, we have to take the turn and we have to change the speed. Both we have to do at a time. Speed will change, magnitude will change, direction will change. At the time also we can observe change of velocity. So change in velocity means delta V bar, because velocity is a vector. So delta denotes change in velocity vector. Delta V bar means, here children, delta stands for change, V stands for velocity, bar stands for vector. Change in velocity vector equals to final velocity. VF stands for final velocity vector minus initial velocity vector. The difference we have to take. Before crossing the ring road, what is the initial velocity? Vi. After crossing the ring road, what is the final velocity? Vf. If these two difference we will do, then we will get change of velocity value. So where Vi is the initial velocity, Vf is the final velocity. So change in velocity is absolute in an inertial frame. So absolute means it never depends on observer. So here change in speed, suppose one observer is here, or one observer is in the car, or one observer is near toll gate. We can observe from anywhere, but the change in velocity in the car will be same for everybody, because it is not relative term, it's absolute term, means it is fixed. Change in velocity is fixed because this frame is inertial frame. This outer ring road is fixed frame, it is not moving, so it's considered as inertial frame. So in an inertial frame, this change in velocity is absolute term, means it does not depends on observer. For everybody, the value of change in velocity will be same. From person to person, it won't change. So this change in velocity is called acceleration. It may be because of change in speed, means because of change in magnitude or change in value. If the change happens because of magnitude, we call it as change in speed, or because of change in direction, or because of change in both. Because of these three reasons, if there is any change in velocity happens, this change in velocity is called acceleration. So we have a new word called acceleration, children, which means change in velocity. Reason may be any one of these, but change happened. So that's why there is acceleration. So here, acceleration means the change in velocity in unit time. Means in 1 second, how much velocity changed. That is called acceleration. So acceleration means change in velocity by time. Change in velocity, what is the symbol, children? Delta V bar. Delta stands for change, V stands for velocity, bar stands for vector. So change in velocity by time. Because change in velocity, again we can write it as V bar, final velocity, U bar, initial velocity. Final velocity minus initial velocity. This difference equal to delta V bar. Because velocity is a vector, so change in velocity is also a vector. So acceleration also a vector. Okay, acceleration is also a vector. So the change in velocity, in what direction change in velocity happens? In the direction of change in velocity, acceleration also will be there. So the direction of acceleration will be always along the direction of change in velocity. Okay. So here change in velocity means velocity minus velocity. Its unit will be meter per second. Because change in velocity also one kind of velocity. Unit is meter per second by time means second. Means meter per second into second or meter per second square. Meter per second square. Meter per second square is the SI unit of acceleration. Its dimension formula. Meter stands for length, one length. Second stand for time, T square. Because we are having second square, L1, T2. L1, T square, if it goes upside to numerator, T power minus 2. So L1, T power minus 2, no mass is involved. So M0 we will write. So dimensional formula of acceleration is M0 L1 T minus 2. So next, average acceleration. So if the velocity of particle remains constant as time passes, we say that it is moving with uniform velocity. Uniform velocity. Uniform velocity. Means suppose if you take a train. If you take a train, so what happens to train? While leaving the platform, it will move, it will increase its speed slowly. It will change its speed slowly. It will increase, positive, speed will increase. But after coming into the middle, for some time, it will go constant. Sometime it will go with constant speed or velocity. Again, reaching another station. While reaching another station, again its velocity will change. This time it will slow down, negative. Means throughout the journey of any object, we can observe change in velocity, either increasing or decreasing or constant. If the velocity is constant, suppose here it is moving from 0 km per hour, next 10 km per hour, next 20, next 30, here it is 40. For 1 hour it traveled with 40 meter per second or kilometer per hour speed. Next again decreased, next 30, 20, 10, 0, like that. So this 40 km per hour, this is for 1 hour it is constant. during that 1 hour journey, the velocity is not changing, velocity constant. So then we can say that the body is moving with uniform velocity. Uniform velocity means change in velocity is zero, means zero acceleration. So uniform velocity indirectly, what is the meaning, children? Zero acceleration. Why? The velocity is uniform, not changing. Acceleration means change in velocity, no change. So acceleration will be zero in that case. Suppose if the velocity changes with time, we can tell that it is accelerated. The object is accelerated. So the acceleration means rate of change of velocity. In how much time, how much velocity changed. That ratio is called average acceleration or acceleration. So rate of change of velocity means how much change of velocity happened in how much time. Relating to time, if we compare, then that is called rate of change of velocity and it is called acceleration. So average acceleration will be taken for throughout journey, total journey. For the total journey, the velocity may increase, the velocity may decrease, or the velocity may constant. So overall, for the total journey, always we will consider average acceleration. Average acceleration. So sometimes we will come across instantaneous acceleration, because in if you observe racing, car racing, the winner will be decided in a time gap of 1 second. In a time gap of 1 second. In a time gap of 1 second, the one car racer may overtake another car racer. Means within less time, less interval of time, we can observe some amount of acceleration at that 1 second. Why? Means it is moving with great speed. So in that particular 1 second, how much change happened in the speed of the car in car race, that acceleration in that particular instant or particular second is called instantaneous acceleration. But it will be small, very, very, very small, dv. dv means small change of velocity. We can observe in dt. dt means small interval of time, like 1 second. So 1 second is at, suppose total car race is for 2 hours. From 2 hours, if we compare 2 hours, 1 second is a very small time, interval of time compared to 2 hours. So in that small interval of time dt, how much small amount of velocity changed, the dv by dt is called instantaneous acceleration, means acceleration at that particular instant, at that particular 1 second. If we take delta v by delta t, so then it is large amount of change of velocity in large amount of time. For 2 hours, how much velocity changed? Then we will make use of delta v delta t. But for small intervals, we will make use of dv by dt. So instantaneous acceleration means acceleration or change of velocity in that particular instant. Next, uniform acceleration or constant acceleration means we have started journey from 0 seconds. Velocity is 10 meter per second. 10 meter per velocity is 10 meter per second. Now after 10 seconds, velocity changed to 20 meter per second. Again after 10 seconds, means 20 seconds, velocity changed to 30 meter per second. Again after 10 seconds, 30 seconds, velocity changed to 40 meter per second. Means 0 to 10, 10 seconds, 10 to 20, 10 meter per second changed. Again 10 seconds, 10 meter per second, 10 seconds, 10 meter per second. Like this, if the change of velocity is in equal amounts, in equal intervals of time, Here time should be equal, time interval should be equal, velocity change should be equal. Then we can tell that the body is moving with uniform acceleration or constant acceleration. Means velocity is changing but in uniform way or like a constant. Okay. So then the acceleration will be given by A equal to V minus U by T, or T will go this side, A into T, AT, or U will go this side, U plus AT, V equal to U plus AT. This formula will come. So whenever a body is traveling with uniform acceleration, for solving problems, we can apply these two formulas, A equal to V minus U by T or V equal to U plus AT. For which body? For any object which is moving with uniform acceleration, for that kind of objects only, these kind of formulas will be applicable. So next, non-uniform acceleration means if the velocity of body changes unequal amounts in equal intervals of time, means in 10 seconds velocity changed 10 meter per second, next 10 seconds velocity changed 30 meter per second, next 10 seconds velocity changed only 10 meter per second. First 10 plus 30, 20, 30 plus 10, 40. Here for 10 seconds 20 meters changed. Again for next 10 seconds 10 meters only changed. Means equal intervals of time but unequal amounts of velocity changing. We can tell that non-uniform acceleration. Non-uniform acceleration. We also have a word called deceleration, or it is also called as retardation. R-E-T-A-R-D-A-T-I-O-N. Retardation. Means suppose here we are going in a car. Suddenly this cycle, this person comes in front of the car. What we will do? We will apply brake. If it is traveling with great speed, because of brakes, the car's speed will be changed, decreased. That decrease of speed or velocity is called deceleration or retardation or negative acceleration. We can also call it as negative. We can also call it as negative acceleration or minus A, because plus A stands for acceleration, minus A stands for negative acceleration or deceleration. Means if the speed of particle decreases with time, we can say that it is decelerating or it is in retardation. So acceleration opposite to this deceleration. The symbol for deceleration is minus A. Okay, children. So next. So for uniformly accelerated motion, means for the bodies whose change of velocity is uniform according to time interval, so then they are said to be uniformly accelerated bodies. In that type of motion, some equations are applicable. They are called equations of uniformly accelerated motion. So we have mainly three equations which establish relationship between uniform acceleration A, initial velocity U, final velocity V, time T, distance or displacement travel S. Means A, U, V, T, S. Means when a body is uniformly accelerating, in that type of body, between these five quantities, there exist mainly three relations. One is V equal to U plus AT, S equal to U plus AT plus, S equal to UT plus half AT square, V square minus U square equal to 2AS. We have three equations which are used to find the relation between these five quantities. So how we have got these equations, that we will learn in our next video. Okay children, that's all for today. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.